Hello everyone, welcome back. I'm excited that you are here because today we are starting a complete Azure load balancing video series. This is the first video of the series where I will discuss what is load balancing and what all load balancing services is provided by Azure. I will also give an high level overview of each load balancing service and then I will discuss how to select an appropriate service for your workload scenario. In the subsequent videos, I will explain each load balancing service in detail with hands-on demo. Now, before we start discussing various load balancing services provided by Azure, let's understand what is load balancing. As you see, I've written it here. Load balancing refers to the distribution of processing across multiple computing resources. We use load balancing to optimize resource usage, to maximize throughput and minimize response time, and avoid overloading any single resource. Load balancing can also improve availability by sharing workload across redundant computing resources. Now, let's start discussing the various load balancing services provided by Azure, starting with Azure Load Balancer. Azure Load Balancer operates at layer 4, that is transport layer of OSI model, and handles inbound and outbound traffic across UDP and TCP protocol. It can be both regional and cross-regional. It supports both topologies. Okay, and it's an excellent choice for internal and external traffic distribution across VMs and services. Okay, it can be public and private, and I'll be discussing more details of how we can create an Azure load balancer when we do a hands-on demo. After Azure Load Balancer, we have Application Gateway, which operates at layer 7 of the OSI model. Layer 7 is the application layer. So, unlike Load Balancer, which directly forwards the traffic to the backend servers without terminating or inspecting the connection, Application Gateway first terminates the client connection, processes the request, and creates a new connection to backend. This allows TLS offloading, application routing, path URL or path routing, and firewall protection while keeping backend servers private and secure. Now let's discuss the third load balancing service provided by Azure, which is Azure Front Door. Now Azure Front Door also operates at level 7, but it is a global service as compared to Application Gateway. So Azure Front Door is a global application delivery network that act as a smart front entrance to your web application. It routes user to the closest or healthiest backend region, accelerates traffic through Microsoft's Edge network, handles SSL encryption, and instantly fails over if a region goes down, ensuring fast, secure, and highly available access worldwide. To give you an example, suppose there is a global airline hub system. Passengers don't manually pick the best route. The airline routes them through the closest hub, avoids delays, and reroutes around disruption, and ensures they reach the destination quickly. The front door does the same for web traffic, picks fastest route, avoid outages, and optimizes performance. Now let's discuss Traffic Manager, which also operates at level 4 and is a DNS-based global traffic director. So when a user accesses your domain, Traffic Manager tells which Azure region to connect to, and after that, the connection happens directly. Okay. So because it relies on DNS caching, the failover isn't like front door. Okay. But it provides a single and effective way to distribute traffic globally. So now that we have discussed all the four services or all the four load balancing services that Azure provides, let's understand how to select the best load balancing service for your workload. Before we discuss which load balancer service to choose for your workload, Understand that each application or workload has a different requirement. And this flowchart is not the hard and fast rule that you should follow to select a load balancer for your workload. This can be taken as a starting point. And remember, whenever you have a workload which requires different service for load balancing, okay, assess each service individually because it is often that effective solution uses more than one load balancer solution. Here in this flow chart, you can see two divisions. The first is for internal clients and second is for internet clients. So let's first understand the internal clients. Okay. Now, if internally, if you but your load balancer has to support HTTP or HTTPS traffic, okay, then you can go for Azure Application Gateway. Now you see the terms here a pass-through load balancer and a terminating load balancer. So what is a pass-through load balancer? So a pass-through load balancer forwards the traffic to backend server without terminating or inspecting the connection. It behaves like a smart traffic distributor, not a middleman that opens and processes the request. So the backend servers, in case of pass-through load balancer, see the original client IP, okay, handles encryption and decryption, and process the full session. But in case of terminating load balancer, which is Azure Application Gateway, the client connection is terminated, and then which offers us the ability to inspect the traffic and TLS and SSL offloading. We can do URL path routing, and we can do check security policies with a web application firewall. Okay. Once it inspects the traffic, it creates a new connection to the backend so that our backend remains secure and private. Okay. Again, if you are handling TCP or UDP traffic, then you can go for Azure Load Balancer. Now, for internet clients, we have the same decision tree. First, we have to check, like first we have to understand if their workload supports HTTP or HTTPS traffic or not. If it does, and if it is globally deployed, then you can choose other Azure Front Door. But if it is multi-region VNet deployment, then you can go for Azure Traffic or Application Gateway, right? And again, if it is not deployed globally, you can select Azure Application Gateway, right? I'm not discussing these application gateway for containers and Azure API management. Basically, if you have only API backend, then you can go for API management. But you can, I'm not going to discuss uh, all these things in this video. In future videos, I'll create a separate topic for all these things. Okay. Now, if it is not layer 7, if it is at layer 4, first we need to check whether it is globally deployed or not. And if yes, and you want to use a pass-through, you can use global load balancer. We said that Azure load balancer can be either regional or it can be global. Okay. So similarly, if you want to use a terminating load balancer for multi-region deployment, then go for Azure Traffic Manager plus Application Gateway. We said that Application Gateway does support TCP and TLS protocol. Okay, and if it is not a global deployment and you want a terminating load balancer, then Application Gateway. Otherwise, you have to use Azure Load Balancer. Now, this flow diagram you can find it on Microsoft.com, right? But again, as I said earlier, this is not a hard and fast rule. You have to assess each service individually to understand which load balancing service will fulfill your requirement. Now that we have discussed all the theory or the high level theory around load balancers, from the next video, I'll be doing a hands-on demo starting with Azure Load Balancer. Thank you for watching this video. See you in the next video.